Hi Math 2 students, this is Miss Van Vickle and this is video 3 in a series of 4 videos all about exponential growth and decay. It's your notes for Tuesday, April 21st, and I'm working problem number 2 in your notes page. And that problem says, a scientist has discovered a new strain of bacteria. The bacteria culture initially contained 1,000 bacteria, and the bacteria are tripling every 30 minutes. It says, write an exponential function to model this situation. So I'm going to use my exponential function, y is equal to a times r to the t power. And I know that a is my starting point, so I want to choose 1,000 for the starting point. And r is going to be 2 because I'm doubling. And I have to be a little bit careful about this t value here. You'll notice that the bacteria are, tripling. I don't want a 2 there. I want a 3. There we go. That looks better. So the bacteria are tripling every 30 minutes. So my starting value is 1,000. My rate is tripling. Now I have to be careful about t. Because what I want to be able to do is I want to be able to put in 30 for the number of minutes and have the outcome be 1 occurrence of tripling. Let's think about how that works. At time 0, nothing has happened. And then after 30 minutes, I want to have this multiply times 3 once. And then after 60 minutes, I want to have this multiply times 3 twice. In other words, after 30 minutes, I want my exponent to be 1. And after 60 minutes, I want my exponent to be 2. So if I use t divided by 30, then I could put in 30 for 30 minutes, and I would have 1 tripling. If I put in 60, the exponent would resolve to 2, and that would give me 2 triplings. Let's go back and read the question and make sure that makes sense. A scientist has discovered a new strain of bacteria that initially contained 1,000 bacteria, and the bacteria are tripling every 30 minutes. That makes sense to me. So part B says, use the model to determine how many bacteria will be present after 1.5 hours. Be careful, we don't want to put 1.5 in for t because we're measuring t in minutes. So what we want to put in is 90 minutes because that is equal to an hour and a half. So I am going to put in 90 for the number of minutes. And I see that this becomes 3 to the 3rd power. And then I'm going to multiply that times 1,000. So let me use my calculator to do that. I have 3 to the 3rd power times 1,000. And that gives me 27,000 bacteria after an hour and a half. It's a lot of bacteria. Then part C says, how many minutes will it take for there to be 200,000 bacteria? So in this case, they're giving me the y value and asking me to solve for x. We have 200,000 bacteria. I started with 1,000, and I'm tripling every 30 minutes. So let's take a look at how we're going to manage to sort that piece out. The first thing I do is I divide both sides of this equation by 1,000. I like to get this piece with the exponent all by itself. And so if I divide by 1,000, that's just like taking off some zeros, right? 200,000 divided by 1,000 gives me 200. So I have 200 on the left, and I have 3 to the t divided by 30 power. So let's write that out. We're going to use our calculator to solve this. Okay, so into y1, we're going to put 200. And into y2, we're going to put 3 to the x divided by 30. Notice I have to put that fraction in parentheses. Let me scoot this down so you can see my screen. And now I'm going to have to use a little bit of common sense to set my window. I want my y max to be bigger than 200. So I don't need it to be as big as 9,000, but let's try 300. And I'm not quite sure how many minutes it's going to take. But let's just guess maybe it's going to take 4 hours. So 4 hours would be 240 minutes. And now we graph and just see if we can see what we need to. And it looks like my educated guess about my window paid off. So second calc, we're going to choose to find an intersection, and we're going to say yes to both of those curves by hitting enter, and then we go up and find the intersection. And when x is 144.68, or about 145 minutes, and t is about 145 minutes, we have 200,000 bacteria. So we could express that as minutes, or if we would like to express that as hours, we could go back and we could divide 145 minutes by 60 and find that that's about 2.4 hours. So part D says, after an hour, the scientist only counted 900 bacteria. He knew this couldn't be correct because there were more bacteria now than when he started. Actually, this should say less bacteria now than when he started. And he decided he must have made something, a mistake somewhere, and written something down incorrectly, because he knows the bacteria are tripling. So what could the initial amount of bacteria have been if he only has 900 now? Again, they gave us the y value, but what we're being asked to solve for is the starting value. And he was gone an hour, so we're going to put 60 over 30 because 1 hour is 60 minutes. So this equation becomes 900 bacteria is equal to my starting value times my rate of 3, tripling, to the second power. 60 divided by 30 is 2. So this is A times 9 is equal to 900. And if we divide both sides by 9, we get A is equal to 100. So it looks like the scientists accidentally wrote down 1,000 instead of 100. And this is it for video 3. Come back, there'll be one more.